And we are live. I can see people joining in. This is day 2 of TestMu Conf. I'm joining in from New Delhi, India. I have Andrew with me from North Carolina. Feel free to let us know where you're all tuning in from. Drop your thoughts in the chat. All right, so we have Marcy from Washington, D.C. That's good to know. Hey from Nigeria. Hello from Germany. St. Louis. Hello, hello, hello. We have people from Barcelona, Slovakia, Seattle. Okay, we have people from all around. That's good to know. And yeah, so we are 1 minute up. I think we have a lot of people already in. So let's kickstart this. Good morning, good afternoon, and good evening, everyone. And welcome to day 2 of TestMu Conf 2026. I'm Harshit Paul, Director of Product Marketing at TestMu AI, and I will be your host for this workshop around advanced web testing with Playwright and AI. Before we get started, a few housekeeping items. This workshop is being recorded, so in case you need to drop off midway, you will get the full recording over your registered email address. We'll have a dedicated Q&A round at the end, so if you have any questions while the workshop is on, feel free to drop them in the Q&A box. If you have any learnings that you want to go ahead and take back with you post this session, feel free to give us a shout on LinkedIn or X. Tag us using the hashtag TestMuConf so the rest of the community could also learn with you. And with that said, let's get back to the workshop. Passing your first Playwright test is one thing, but keeping hundreds of them fast, reliable, and maintainable while the app changes underneath you is a whole different ballgame. And that's the job we are doing in the next 90 minutes. We're going to deep dive into Playwright strategies that keep a test suite alive as it scales, where AI genuinely helps versus where it just adds to the noise. And walking us through it is Playwright Ambassador himself, Andrew Knight, Senior Director of Product and Engineering at Cycle Labs. Many of you will already be aware of him as the Automation Panda. He's the creator of Boa Constructor, the .NET screenplay pattern. Hi, Andrew. Welcome to TestMu Conf 26. The stage is yours.
Hello. Thank you. Thank you so much. And hello, everybody. Hope we're doing well this morning. Let me share my screen here. We've got quite the action-packed 90 minutes going on here. Boom. So we are going to talk about advanced web testing with Playwright. I'm going to set a poll out here just to kind of gauge where people's skill levels are. Playwright is not new anymore. I used to say it's the hot new framework. Well, it's still a hot framework, but it's not so new. It's been around for quite a few years now. It's hard to believe. The march of time is relentless. But using Playwright with AI is relatively new. And so that is where we're going to focus our efforts today. Even before the age of AI, I was a big proponent of Playwright because it solved so many problems and made testing a lot easier. Now with AI rocket boosters, it is wild what you can do with Playwright. And so that's what we're going to cover today in this workshop. As Harshit said, my name is Andy Knight. I am the Automation Panda. I am located in Raleigh, North Carolina, USA. Currently, I am the Senior Director of Product and Engineering at a little company called Cycle Labs. We focus on building excellent test automation for the supply chain and warehouse management world. Rather niche, still kind of cool. For a decade, I was rank and file SDET, building solutions to testing problems. I took a weird left turn into developer relations. Now I am on the building side of things in product management and engineering. I have a great team, and we're trying to change the world. So a little bit more about me if you didn't know me. I like cool cars, cute dogs, and excellent software. That's a bit about me personally. Feel free in the chat to let me know what your favorite car is. This is my 2006 Mercedes C280. If you know me, I also have a 1970 Volkswagen Beetle. It's cool stuff. If you want to keep track of me after this workshop, you can look me up at automationpanda.com. That's my professional site. There's also autopandamotive.com if you want to look at cars and stuff. And as always, there's LinkedIn. If you just search Automation Panda, you will find me. And speaking of cute dogs, these are my cute dogs. The gray one, her name is Suki. The cream-colored one, her name is Mochi. She's only 8 months old as a puppy. Love them. We all work for something. So, in other news, I actually have a new LinkedIn Learning course. It's Playwright with AI. So if you like what you're learning today and you want to go deeper, feel free to check out my LinkedIn Learning course. If you just type into LinkedIn Learning Play with AI, or you scan this QR code, you will find my new course that dropped back in July. Is full of great stuff. Yep, enjoy. So let's get down to business. Let's talk specifically about Playwright. Yes, what is it? For those who don't know, it is a modern open source web test framework from Microsoft. The way it works is that it manipulates the browser via super fast debug protocols. This is different from how Selenium works with its WebDriver protocol and how Cypress historically worked. It's almost like going in the back door. What this means is that in terms of raw execution time of the interactions and verifications, Playwright is the fastest, and there are many benchmarks out there that show that. But Playwright is also distinct in how it handles things like setup and browsers and whatnot. So instead of working with the big name, big box browsers like Google Chrome or Microsoft Edge or Apple Safari, it really works more with the browser projects that undergird those bigger browsers. So instead of directly testing Chrome, you're testing Chromium, which is the open source project underneath Chrome and Edge, and I think a few others. So there are the three core browser projects, Chromium, Firefox, and WebKit. And when you set up Playwright and install it, it manages those browser projects for you, pegged to the version. So you never have to worry if your WebDriver executable fell out of sync, or if there's an update overnight that wipes out your CI, right? Playwright keeps that all controlled as part of its developer experience. Now, you can test the big browsers for Google Chrome and Microsoft Edge. They have a thing called browser channels where it'll channel through to the browser that's on your machine. So that is still a possible workflow. But note that you cannot test the big browsers for Apple Safari or the main Mozilla Firefox. What's really nice about Playwright is all the goodies they put into the framework. It has things in it, excuse me, like automatic waiting, test generation, a UI mode, a code generator. And that's all stuff that's baked into the core offering, aside from what AI can do for you. Another nice aspect is that with Playwright, you can test UIs and APIs together. Oftentimes, I recommend using APIs to stage data for setup and cleanup, and then using the UI to exercise the whole workflow. And it has multiple language bindings. The core binding is for Node, so the programming would be in JavaScript or more preferably TypeScript. But it does have packages in Python, Java, and .NET for C#. I will say the best version is going to be that Node binding because that's the native one. And in Node.js, they give you the Playwright test framework that goes with it. Whereas in the others, Python, Java, .NET, Playwright is more of just an engine that you have to plug into one of those frameworks. So PyTest for Python, JUnit for Java, MS Test or whatever for .NET. And finally, Playwright is natively AI supportive. It has an MCP server together with a set of agents out of the box, as well as a very powerful CLI that couples together nicely with skills. And so we're going to use those today in our workshop. So all the goodness hooked in directly to your AI coding agent of choice makes for an awesome web testing tool. Okay, so let's see. Oops. Do we have... I'm looking at the poll here just as a quick pause. How many of you have used Playwright with AI before? Most people have done a little bit with Playwright in AI. For some people, Playwright is completely new to them. About a fifth of you are Playwright with AI champions. That's awesome. That's awesome. Glad to have everybody here. I'm hoping we can all learn something new. Fantastic. Okay, so for those who are new to Playwright, I do want to hit up some key conceptual points here. As I said before, Playwright is freaky fast. It's like Jimmy John's, man. Get your subs. It is not just in the raw execution speed of interactions and verifications. There are certain the efficiencies also come in how it manages its browsers and thus how it also sets up its tests. If you have done, say, Selenium WebDriver testing before, you're familiar with the best practice of every single test gets its own WebDriver session, right? And that can be very heavyweight because for every single test during the setup, you have to launch a new WebDriver session, meaning it has to go to that executable, kick open the browser, and that can take 3 to 5 to up to even 10 seconds. And that's if you're doing it locally. If you're doing it remotely, it can take even longer. And then at the end of the test, you have to tear that down, which is another couple seconds. So every single test, you're spending several seconds just to do setup and cleanup, just to get the browser open. Multiply that by 100, multiply that by 1,000. Your overall test suites are taking a whole lot longer just for those mechanical operations. Playwright does it much more quickly. Not only is it more efficient in the footprint of the browser because it's using the browser project rather than the full big box browser, but instead of having one browser instance per test, Playwright uses one browser instance per worker. What? That means that multiple tests could be using the same browser instance? Yes. Now you might be thinking, holy crap, that's dangerous. That violates test case independence. Why would you do that? Well, there's one browser instance, but every test gets a unique browser context. And a browser context is like a protected session within a browser instance. And you can have multiple contexts together in the same browser instance that are safe. So all the things like your session state, your storage, your cookies, it's almost like it's its own incognito session for that test. And so that way you don't have the perpetual setup and tear down of the browser. Every single test case just spins a new context and it's lightning quick. And so your setup and tear down times go from multiple seconds down to milliseconds. Now you can have, like I said, you can have multiple contexts. And so you can have even parallel tests with different contexts and it'll be okay. And then within each context, you can have one-to-many pages. Now, a page is the object through which Playwright will interact with the page in the browser. Typically, most tests only ever need one page at a time. But if you have the circumstance where you click a button and it opens in a new tab, you can have Playwright spin up a new page to go interact with that new tab that just opened. And so one context can have multiple pages. This overcomes the limitation that, say, Cypress had, where Cypress could only ever have one page or tab at a time. So browsers, contexts, pages. This is how Playwright manages the browser. Every single test case will interact with the one browser instance for its worker, spin up its own context, and give you a page. And if you need more pages, you can create more. And at the end of the test, it'll automatically close the context. All right. Now, I've mentioned some other test frameworks before. The big three have been in testing for a while: Selenium, Cypress, Playwright. I don't want to beat a dead horse here. I'm not here to wage wars. I just want to give a quick visual of a comparison between these. They're all good for different purposes. Like, for example, at Cycle we actually still use Selenium for some things. We use Selenium and Playwright. But basically, in short, Selenium's the Kingpin that's been around forever. It's an open source project, has multiple people, multiple companies contributing to it, works with all the big box browsers, has multiple language bindings, is great. It's what really kickstarted this whole open source web testing thing. But it is just a tool. It's not a full framework. You have to build the framework around the tool. And so there's a lot that you have to know and a lot you have to build. It's very DIY. Cypress became popular starting about 10 years ago as a web test tool targeting developers. It was the first one that really understood the need for good developer experience and making that enticing and easy and fun. But it is limited to the confines of a browser. It is JavaScript only, and it has some other limitations as a result. So but if you want to make web testing easy and fun, that one was great. Playwright, I felt like, is the best of both worlds. It has good developer experience. It has a lot of safety things. It's got a lot of cool features in it. It really hones in on efficiencies and optimizations. And in the age of AI, I feel like it's probably the best equipped, and we'll see that today. So I see we got some questions in the Q&A. Feel free to pop in questions as we go. I'll scan from time to time to see if there are quick ones I can answer. Otherwise at the end, I'll try to get all of them. Let me see here. Some of these questions we'll answer in the course of doing it. Oh, wow. Okay. Yeah. Okay. So I won't answer any specific questions at this moment because it looks like they'll probably get answered as we go. But feel free to keep popping them in there. Let's continue on. So we've talked a little bit about Playwright. Seems like most of you already know kind of the basics. So I don't think it's super valuable to beat on the basics much more. What I want to do is I want to start talking about how Playwright works with AI, because that's where I think there's a higher level of understanding that can really, really help supercharge your testing and developer workflows. So to start with, I want to clarify some terms and some building blocks for AI-powered development. We all have been using things like Claude and Cursor or Copilot. And I think there can be a muddling of the understanding of what's a rule, what's context, what's a skill, what's an agent. So let's clarify that here together. So when I talk about a coding agent, I'm talking about the thing that orchestrates the model, rules, subagents, and tools all together to produce some sort of end-to-end result with code. So examples of coding agents would be Claude Code, Cursor, Copilot, Codex. They all seem to start with C for some reason, right? Open Code would be a free and open source one. So when I say coding agent, that's what I'm referring to. Now, there's also the model. The models are the thinking piece. They're the LLMs responsible for all the reasoning, planning, generation. And so the coding agent will take stimulus of some kind, like a prompt from a user, and they'll send it to the model to do the thinking and reasoning to get an answer back. Models are stateless. You have to put in a question or a prompt, and you get out an answer. So models are good at answering questions. There are also rules that are standing instructions to your system prompt that govern agent behavior. Now, the thing about a rule is that it's meant to be always turned on. It's meant to be unconditional. When we provide rules to a coding agent for how it should work, it's saying you will always do this. Every coding agent has a way to set rules. It's usually like a little file or something. We specify them in Markdown. The concept is that the agent is always supposed to follow them, so it takes it very seriously. There's also this thing called a subagent. A subagent is a spawned worker that depending on your coding agent, will have its own context window, its own tools, its own directives. The idea of a subagent is that you're meant to give it like a persona or a goal, and it's meant to go do something for you and then come back. And so we can write subagents, again, in Markdown. They're meant to be bigger and broader in their directive, because we also have these things called skills. And what a skill is meant to be is more narrow, more targeted. A skill is like a packaged prompt of instructions, again, written in Markdown, but it's meant to do a specific task, and it's meant to do it within certain bounds with well-defined capability, and depending upon your coding agent, within the same context window from where it was called, whereas a subagent is dispatched. We also have this thing called MCP, Model Context Protocol. This is a standard that Anthropic has put out there, but it's kind of become a standard way in which to provide tooling to AI agents and models and all. So Model Context Protocol is an open standard for connecting agents to external servers. So whereas the coding agent is this orchestrator and the model is non-deterministic, and so the things that it can do could go all over the place. There are times where you have certain tools that are meant to be deterministic. Write this file call this API, do this thing, right? Any of those deterministic kinds of tools, you can create an MCP server for. And the MCP protocol tells the agent like, oh, this is how you call these kinds of tools. It makes it visible, easily visible and callable from the agent. So it can take these things and all the standards and what's the word I'm looking for? The integration points. It can take that and give it to a model so the model knows how to work with MCP. And so you'll see a lot of companies now saying, oh, we have an MCP server to do all these things. In fact, my company, Cycle Labs, has a Cycle MCP that controls how our test automation goes. It's pretty cool. And then there's also the CLI. CLI is another form of tool. An MCP server is a tool because it's a deterministic process of what to do. A CLI is a tool because it's another way of calling a deterministic process to do something. The nice thing about CLIs is that they're local. They're usually pretty fast. You can use CLI, any kind of CLI, right? There's nothing particularly special about it. You've been using command line your whole life, probably in the software realm. So AI is really good about using CLIs because it's all text-based. There's a manual page for how you do everything. It can learn that and then call your CLIs. And in fact, if you've been using something like Claude or Cursor, you've probably had to give permissions of, can I call this command? That's what it is. The reason why I list both MCP and CLI is because Playwright offers both. And you might be wondering, why would you choose one over the other? If you're doing local development on your laptop, CLI is usually the better way to go for tooling. If you are doing something in an agentic workflow that's distributed, MCP is the way to go because it's a way you can have, network protocol for commanding things what to do. So all these things together, this is what we call like our AI stack. These are all of the things that come to place when we are trying to use AI to develop our projects, whether it's some sort of web app, some sort of API, or we're just trying to add tests to it. So, bam. Oops. Okay, so what is the AI testing process? Now that we know what the stack is, how does that relate to Playwright? All right. The process has 3 steps. In general, you can customize your process, of course, but in general, the big 3 steps, and this is what Playwright kind of guides you towards. First step is to plan. What we want to do is we want to bring together all of the information and all of the intelligence for what to test, right? And so with Playwright, it provides skills and tools to explore your app, read different specs, and ultimately come up with a set of test plans written in Markdown files. And we'll generate these today, and you'll read them and see like, wow, it's actually pretty good. Once you have those test plans, the next step in the testing process is to generate test scripts based on those plans. So you had the kind of spec for what you wanted your test to do based on what the app is, based on what your other specs are. Now what Playwright with AI will do is it will produce executable spec.ts files with the TypeScript call or with the Playwright calls to run your tests. And the third step is to heal, right? We know that testing is never perfect. We know that AI sometimes gets things wrong. We know that sometimes we get things wrong. We also know that sometimes in the future, we change our apps and what was right before becomes wrong. And so the third step is to heal, meaning, hey, something ain't right. I've got a broken locator. I've got a timeout. We got to fix this. And so you can instruct Playwright with AI to fix failing Playwright tests automatically, right? Sometimes this might happen after the first generation got a locator wrong. It might happen if you've changed the app in a way that you want to change it and you need to go update the test. The one caution I would give with this is sometimes just because the app changed didn't mean it was good or intended. So always review your test failures before you initiate healing, because sometimes you might have had something break in the app and the test actually caught it, right? But if it was a meaningful change that you deliberately made, like you changed the button, moved the page, whatever, then you can have the AI update your test automatically. Plan, generate, heal. It's a very powerful workflow. It mirrors what we see from the behavior-driven development world of discovery, formulation, automation. Discovery is like plan, formulation is like generate, automation is like heal, right? Cool tie-in. So, with all this in mind, we know that Playwright has its MCP, it has its CLI with its skills. We could just go hog wild, generating tests to Kingdom Come, right? You may have even tried to do that. Been like, hey, Cursor, Claude, Codex, whoever you are, make me some Playwright tests. And it puked out a bunch of test code, and you tried to run it, and you're like, wow, this is heckin' terrible. And then, AI can't replace the human tester. It's not good enough. It'll never be good. You always need to do that. You can't trust this. It's bad testing. And I'm like, fair. But how did you set up Playwright with AI for success? Did you literally just try to one-shot a prompt? Did you even try to go through the workflow? Did you give it the context it needed in order to be successful? Right? Because what we are finding with AI tooling is that it's only as good as what you give to it. Now, there's a whole discipline of prompt engineering that was like 2 years ago. The idea of how can you carefully formulate your prompts such that you get exactly what you want out of it. The prompt engineering is still important, but the limitation of it is that there is so much contextual information that goes along with software development that you can't just pop it into a prompt every single time you need a change, right? That's untenable. And so what the pattern is instead is that you want your coding agent to be able to look at the whole scope of your repository and pull appropriate context in as it's working together with the model. And furthermore, you can help it do that by providing specific contextual information. And so that's where we come to what's the discipline of context engineering. How can I provide everything AI needs to know about my project? It could try to glean from the code itself, but if you can provide additional documentation, or you can provide more structure in how you want to command it to do things, you will get much, much better results. These act like guardrails. These act like rules. And so you can really make the AI a little more deterministic. And so what are things that you would want to put into your context engineering? Things like your tech stack, things like your architecture. You can even put diagrams in there and AI can read them now. Any of your development conventions. Do you have coding standards? Do you have particular design patterns that you favor? Also, any quality and testing standards that you have, right? What does your testing strategy look like? Are you taking a pyramid approach? Do you have unit integration end to end? What frameworks are you using? All that kind of stuff. Domain knowledge. For example, at Cycle Labs, we work in the supply chain space. We deal with testing enterprise systems that are very big, very old, and very complex. And so you can have Playwright try to do an app exploration, but it's only going to get so far on its own. You could provide information about these systems, like how does, let's say, Blue Yonder WMS actually work? And then also product behaviors, right? Think about all the Jira tickets, or insert your own ticketing system here where you spelled out user stories and acceptance criteria and so on and so forth. All of that is contextual information that could be very, very valuable to AI. For example, like you could have, your user story with your acceptance criteria. You could derive test cases from that. That's context that could be put into your project. The next step above context engineering is what we would call spec-driven development. It's one thing to have all of the contextual information available for AI to osmose, but spec-driven development turns that into a more directed process. The idea behind spec-driven developments is that the core artifact of your development process is your specification. If you can describe it, you can do it. And AI makes this possible now more than ever. This is something that the BDD folks like myself have been preaching for years and years and years, but you always had to have humans running the process and being particular about it. AI makes this so much simpler, right? Because ultimately, when we're building software, nobody cares what language you wrote it in. Nobody cares how much test coverage you had, right? What people care is about the behaviors that you're delivering, right? If you're developing a banking app, you need to make sure people care that they can log in and check their balance and make transfers, right? They don't care if the backend was Node.js or COBOL. Nobody cares, right? And so these behaviors in the software are very human oriented because software is meant for people. We are the ultimate users. We are the consumers of the value we're building into software. And so when it comes to these behaviors that are human centric, we tend to describe them and explain them in plain language, right? Right? When we say, like I just said now, hey, I want to be able to log in and make a bank transfer. That's plain language. Right? We can take that plain language and write into a set of specifications. Now we do it a little more formally than that, right? We have things like user stories, acceptance criteria, Gherkin scenarios, so on and so forth, right? But we can specify and we can put it in something like a markdown file. And then we can have AI tooling and process say, hey, you see this specification, implement it in this project. And AI is really good now about code generation and implementing features based on spec. And not only does that work for product code, but that also works for test code. Because now what we find is that if you have the right spec and you described it to do what you want, you can have it generate your product code and your test code together as side effects. They're just outcomes. It's almost like, you hit the compile button, boom, right? Now you still need to check and review and make sure it all works. But this is the fundamental way in which spec-driven development works. It puts the focus on the behaviors you're trying to develop, and everything else is just an implementation detail. And so how can we put the specifications at the center of this process? How can we carry that through? And how can we build up our specifications in a sustainable way such that when we're building on top of it in the future, we can refer back to it for context? And not just us, but the AI can refer back to it for context, that it can use, they can even go back and maybe tweak some specifications as necessary. Like this is the brave new world. This is what AI is enabling us to do, right? And we can move a whole lot faster and deliver a whole lot more value to our users by doing this. And so that's how we went from prompt engineering to context engineering to spec-driven development, or spec engineering, maybe, I don't know. Right. And so when I look at a tool like Playwright that is already very adept at complementing developer workflows for things like web apps, anytime you would make a spec, you can have rules to say things like, hey, when you generate this code, make sure you generate your Playwright tests and use the skills for it. Amazing. Development and testing are two sides of the same coin. So together, these practices make the AI testing loop far more effective so that you're getting less slop and more meaningful outcome, right? If you can describe it, you can do it. If you can describe it, you can do it. We can all be builders with AI, right? My background was in testing and automation. Yeah, I could do code. I went to school for CS. I always viewed myself as an engineer. I've built web apps before, but they were always, kind of dinky. I was never really satisfied with how they looked. They were never like fully scalable because I never identified as a web developer. With the powers of AI, I can develop full, beautiful web apps now and have them thoroughly tested. Like it's a brave new world. So let's turn a lot of these patterns into rules that can guide our project. Any of the best practices you have in mind for your projects, for how you want to run things, you can set them as rules and context and skills so that as you're directing AI to develop your product code and your test code, all those things get baked in. So here are some examples. I recommend doing step-by-step development. You don't necessarily want big bangs or one-shot prompts. What you want to do is have kind of a flow where you're going through things step by step. You're doing small bite-sized features. You do this, you do this, you do this. And it's a little bit, you might think it's a little bit slower than just trying to one-shot it, but ultimately what you're doing is you're making sure care and quality are happening as you go. And so you get this done, done. This one, boom. This one, boom. Ship, ship, ship. And it feels almost like you're surfing on a wave as you're doing this. Same thing applies for testing. Do tests in small batches for focused areas. Do these tests, then do these tests, then do these tests. Also, it helps very much to have clear features that are specified. So I always like to, even with AI being full plain language, I still like to write 3-part user stories. As a somebody, I want to do something so that I get some outcome, right? Because that frames it very clearly in terms of who my persona is, what the desired behavior is, and what the verification for that outcome is, right? Why am I doing it? Who, what, why? Also, I still write my acceptance criteria in Gherkin, given, when, then. Why? Because it forces things to be in a range, act, assert, keeping everything that you want to check to be verifiable, independent, and atomic. You can also bake in rules to say things like, hey, when you're generating new web pages, make sure that all testable elements get data ID or data test ID attributes automatically. We've all been in that position where we've had to test a page where the DOM structure was just atrocious, right? Why can't the developers add IDs for us? Boom, bake it into your rules and context for your project, and you will never lack having those IDs again, because AI will always insert them for you. Or here's another thing. I strongly prefer using page objects with Playwright rather than having raw calls, right? If you just let Playwright generate the tests out of the box, it'll create your test scenarios with raw calls all the way through. I always add a rule to say, hey, use page object model based on, oh, here's Playwright's doc page to show you how to do it, and create fixtures for those for my tests. And so that way, every time Playwright generates, boom, it's always using page objects. Oh, and I just mentioned fixtures. I always use fixtures for setup. So I have another rule in there to say, hey, wrap page objects with Playwright fixtures for clean teardown, right? Boom, boom. Now I never have to go back and do it manually. I never have to make a second pass. It's just baked in from the start. And also, this one to me is the kingpin. I said before, development and testing are two sides of the same coin, right? If you're doing spec-driven development, product code and test code generates from the same source. It doesn't need to be that you have to prompt separately. You can make rules and say, look, every time you generate new product code, generate the tests that go with it, and refer to that whole body of context about my testing strategy and my expectations for that, right? You can also add rules to say things like, hey, every time you generate a test, run it to make sure it works. And if it doesn't align to what the product is, make sure you align it, right? So all these kinds of things, all these little nitpicky kinds of things that you'd have to do as a human in the past and hope you don't forget, you can bake in. It goes even farther than this, because I've worked a lot in startups. In fact, my company right now is a startup. And when you're working on a new kind of project or a new kind of products, there is way more that needs to be done than you can possibly accommodate. And so your entire product plan is about trade-offs. Should I do this instead of worrying about that? And as a result, there are a lot of lesser concerns that just get that people don't do, that they ought to do, and they know they ought to do, but they don't have the time or resources to handle. I'm thinking about things like actually doing test automation, or handling accessibility concerns, handling security concerns, right? All these extra things that should be part of a project. But in terms of when you have a limited time, you have a limited runway, you're trying to find product market fit, historically, the development teams have not focused on that from the start. They've always been left to later, right? With AI, you can bake it in from the start. You can say, yes, I want to make sure that we're generating tests as we go. I want to make sure that every web page has an accessibility audit, has a performance audit, right? And so that all these extra concerns that go along with what should go into an app and what the development and testing processes should be, if you can think about it and you can just put it into the rules and context, then it will carry through and you get it almost for free as you're generating. It's pretty incredible. So think in terms of what AI can unlock for you. So a question I often get is, how can we do better cross-team collaboration between different roles, between biz, dev, and test, and specifically between developer and tester? AI really helps us bridge this gap, I think. Some techniques that I could recommend, try three-way programming. We've always talked about pair programming, right? But now you can have three-way programming. You can have a developer, a tester, and AI building things together. And why that's really nice is because you might feel like you're moving slow, taking two people to do one task, but ultimately you're all ping-ponging together. You're all learning together. And so you don't have to open a pull request, throw it over, and wait, right? You can correct things right away. You can review things. You can have crucial conversations right in the moment and just keep steaming forward. Also, AI can help you focus more on specs and reviews and less on the actual nitty-gritty implementation details, right? Everyone can contribute to writing specs. Why? If you can describe it, you can do it. Everybody can contribute to reviewing the AI output. Why? You hit the run and you see what it did, right? That's what's really going on here. And so quality really becomes a team sport because you're more able to build quality in from the start rather than play a blame game at the outcome when it wasn't what you expected. And finally, you also have a clear division of responsibility, right? With AI, it's easier than ever to bake in the automated tests as part of developer workflows, right? And so the testers can focus more on exploratory testing and product insights, right? I think as we move into the future, what we're going to see is that testers as a role are naturally going to gravitate more either towards developer roles if they're focused more on test automation, or product roles if they're focused more on the holistic side of things, right? We'll see how that goes. So the test automation system, what we want to do then is not just develop a collection of tests, but we actually need to have a system by which these tests are running and delivering value. In the AI age, things are moving faster than ever. We're slinging code like never before. How do we build a system to make sure that this all shakes out, that we're actually getting value out of the tests that we're generating as we go? And so it's multiple part thing here. In terms of your local developments, we should be running tests continually as we're developing new features. And so, like I said before, it's like when you develop new product code, you should be developing the test code that goes with it, and you should have it running to make sure it's all good. You can also have AI agents detect which tests are being impacted by code changes before running, right? Another good technique that can make this helpful on your local environments, if you can containerize things, right? Have that baked into your process too, so everybody's kind of working at the same stuff. Then when it comes to your CI/CD pipelines, remembering that continuous integration is the production system for test automation. I'm going to say that again because we all run tests locally and then we'd like to put them up in the pipelines. A CI pipeline is the production system for test automation because that's where they run for credit. That's where it's visible. That's where the customers who are the consumers of those results are. CI is a production system. We need to make sure that we have high standards and protections for CI as a production system for test automation. So we want to make sure that we have, excuse me. We want to make sure that we have reliable pipelines, reliable tests. We want to split it up and parallelize as much as possible. We want to make sure we know what our dependencies are. Anytime we can, cache things like node modules and Playwright browsers, use pre-built images or pre-built containers, right? Because ultimately, production needs to be fast. I need fast feedback. So if I commit a change or open a pull request, I need to know in rapid time if it was good or not, right? I can't have test pipelines take hours. I need test pipelines to take minutes, right? Because we're trying to move fast. We can't let these things become gates or bottlenecks. Alrighty. So how do we scale up our test suites? I've got a playbook I run. Scan the QR code here. You can read the article I've written on it. But there are basically 5 things in order I recommend teams do. First of all, run your tests in parallel. That is the biggest way to get speed ups when you're running at scale. In order to do this, you need to make sure your test cases are independent. They're not going to collide, any of that kind of stuff. But running in parallel is the highest impact step you can do. By default, Playwright will run tests in parallel across however many workers your machine can handle. Nice, cool thing about the framework. Number two thing, make sure you're implementing proper weighting, because if you've got hard sleeps everywhere, it kills your runtime. If you got flakiness in there because it's not weighting properly, you can never be sure of what tests are working, which ones are failing. Again, Playwright shines here because Playwright has proper weighting built into the calls, unlike other tools where you'd have to explicitly handle it yourself. 3, use performant infrastructure. Make sure that you have control over your CI systems. The machines are powerful enough. You've got scaled up hardware. You've got scaled out execution grids, like TestMu. They have a whole grid in the cloud that has like, I forget what they call it, like hyperscale or something, or like to the max super speeds, right? That can help speed up your thing once you have parallel execution and proper weighting. 4, write atomic tests, meaning each test is independent, individual, focus on one behavior, short, sweet, to the point. And make sure that you're arranging your tests efficiently, right? The whole setup and teardown thing. Sometimes I've seen tests that take like 10 minutes to set up a whole bunch of data that they don't even need, right? Don't do that. Use APIs for your data injections rather than UI traversals. All these kinds of things can really save time on a per test basis. And again, Playwright helps with that. Like I mentioned before, how it handles the browsers, shaving off several seconds per test, huge difference at scale. So these 5 things, check out my playbook. Playwright works very well with them, really helps speed up your tests. Okie dokie. So, woo. Who wants to see some code? I do. That was a lot of talk. Let's jump into a project and see how all of this works together. I have a little web app. I've called it Buggy Board. You can get it here on GitHub. What I'm going to do is I'm going to pull up this project in Cursor. I'm a big Cursor fan. That's what I use as my IDE and coding agent these days. I'm going to create a branch called TestMu 2026. And we are going to set up Playwright and start generating tests against the behaviors of this app so that you can see this AI workflow that I've just been describing. So here we go. Increase the screen size here so everybody can see it. Okay, so like I said, I've got my Buggy Board app loaded up in Cursor. If you were to clone it, actually, you know what? Let me put this link in the chat just so it's easier for all of y'all to get it. That way you're not sitting there scanning QR codes and stuff. Boom. Oop, that link didn't quite work. Hang tight. It's got spaces in there for some reason. I'm sorry. I promise I'm prepared. Let's try this one. Okay, that one should work. Ta-da! Right, it's out there. It's on GitHub. Yay, GitHub. Hope it doesn't go down again. Buggy Board. Hey, look, I mentioned my Beetle. There you go. But yeah, this is free, open source. Feel free to knock your socks off. If you would like, you can try to code along with me. If not, you can sit back and watch and know that the resources are there. Either way is cool. So when you first get the Buggy Board app, you're going to want to run npm install. That sets up all the dependencies for it. Oh, I've got vulnerabilities. Imagine that. That sucks. I'll fix them later. npm run dev is how we would run the app. And so this is an app that is React on the front end, uses Vite to run it. It's got an Express API on the back end. It uses a SQLite database. This is meant to be a tiny little app for demonstration and education purposes. This is not production ready. This is not hosted anywhere, right? This is just meant to be like a developer's application. So let's pull it up. Localhost. Oh, come on now. There we go. Oops, let me start fresh. So when you bring up the app, you'll see a login page. The user credentials for login are stored in like a users.json file in the project. Username is Buggy, password is 1970 Beetle. Oops. And so you log in, and boom, what we see here is a bug tracker. And so what we could do is we could create a new bug. Carburetor is leaking. I don't know. You can give it a severity. You can assign it to an owner. Gasoline is everywhere. Right? You can save it. Boom. And next thing you know, hey, look, my bug appeared in the list. So if I click it, I can see, oh, I can edit the information of it. Or I could even go so far as to delete the bug. Right? There's all the open bugs. There's the closed bugs. You can sort based on different factors. Right? You can search any bugs in the engine, anything with fire, right? Carburetor, right? So it's got all these kinds of things. You can see which bugs are open and which ones are closed. So here we have a very simple web app. It's complex enough that it's got multiple views. It's got authentication it needs. It's got a richness in microcosm, but it's not overwhelming that you can't figure it out. We will use this as our application for testing. Now, if I go back to the code, what's it look like inside of this app? Well, y'all have probably never seen this app before. I have. Anytime you're coming to a new project, if you're not sure what's going on, what can you do? You can spend a week poking through the Explorer and reading all the files in the code, or you can ask AI, please explain what this app is and how it works. Boom. Right? Outsource the thinking. Right? So I know this is a very simple, trivial app, but sometimes we deal with highly complex applications, and we're thrown on a project and expected to just go and figure things out. And that can be overwhelming and it can be intimidating. So a lot of times what I do is I just ask AI, like, what's going on here? Even in the projects in my company, like I've been at my company for 3 years, there are still things I don't understand because I've never had to poke them yet, right? And so AI is a godsend to help me poke and peruse and learn. Remember, I made a flippant comment, outsource the thinking, haha. Use AI as a tool to help you do your thinking, right? So here, what's it say? Buckle up for a tour of this little beetle of a bugger project. Buggy Board is a small educational bug tracker. It's a system under test for this course. Sure. What can you do? You can log in. You've got a board page. You've got all these different behaviors. What's the tech stack? Hey, like I said, boom, all these cool things. React and Vite, Express, SQLite. Oops. All that good stuff. How the project is developed, blah, blah. Okay. So we can do a grand tour of this app. Where I really want to bring your attention to is this specs folder. I had mentioned that that I like to use spec-driven development, where I can describe what I want for the behaviors and specs, and then have the AI use that as part of a process to then generate code. Here in the specs directory is where all of that is controlled. I have a project constitution that explains how this project is to be run. This document is the supreme reference for how all this operates. So there are different articles that guide how development works. For example, Article 1, specs as the single source of context. All product and engineering context shall live in the markdown under the specs directory. Right? It even gives a little table of contents of what's going on in here. Right? Cursor shall enforce the specs. Progress is tracked in one place, a progress MD. There's a workflow. Human adds and edits features. Human directs the AI to implement. The AI reads the relevant specs, stops for human review, and then the human directs to the next spec. This is a very basic, how to say? This is a very basic workflow I rolled it myself. So this is very DIY. There are tools out there that you can formalize the spec-driven development process if you want something more rigorous. For example, there's a tool out there called Spec-Kit that comes from GitHub. There's another one called OpenSpec. There's also one that's related called Superpowers, right? The nice thing about AI is that you can kind of define what your own workflow is going to be. I chose to define it without using any sort of tools or framework here for the sake of giving the example of how it works. All right, you can roll your own like I did. If you want to be more formal, you can grab a tool like Spec-Kit. Either way is good. So I have my project constitution, and in fact, I have rules for Cursor to instruct it to read the constitution and use the spec directory. Under here, there are sections. I have things for design, things for engineering, things for product. So for example, like under my product folder, I have the vision of what this Buggy board is. Buggy board is a basic bug tracker web app. It will serve as the system under test. You know, I have themes, I have main views. All of this I put in here and generated and worked with AI to bring about what you saw. For the engineering context, I have things like API conventions or coding standards or test automation patterns, right? All of these are engineering concerns. And so every time it generates code, it makes sure to abide by these engineering rules. There's also, let's see what else we got here. Design rules about the look and feel and the theme and the colors. All that's in here. So all of that helps guide my project forward. It's the guardrails. Now, here's where things get interesting. So I have all of my features. Every time I want to add a new feature to this application, I write a feature here. And so, for example, here's what the create bug feature looks like. I have a user story. As a Buggy board user, I want to create new bugs so I can record and track issues. I have all the data that goes into an issue. There's a workflow design that I've documented. There's stuff that's out of scope. And then there's also my acceptance criteria written in Gherkin. So when I would generate this and it goes into the app, it's very clear how it all goes about. So that's basically how this app was developed. Now, this project in its current form, in its current branch, does not have any test cases for it. I'm going to show you how you would add Playwright to a project like this and start generating tests. So we are, what branch am I in? Okay, I'm in the main branch. I'm going to git checkout B. What was the name of the branch I said we were going to use? TestMu 2026. Oopsie. Come on. Oh, come on. Click the damn thing. There we go. Git checkout TestMu 2026. Okay, so now I'm in my branch. What we need to do is we need to set up and install Playwright here. So if you're not sure how to do that, you go to playwright.dev, which I'm doing right now on my other screen because I can't remember how to do all the things. But installation, okay, where's the command? npm init playwright latest. Let's do it. Where do you want to put your end-to-end tests? Test directory is fine. I'm not going to add a GitHub workflow. Install the Playwright browsers. It's going to set up Playwright test. Here we go. Boom, boom, boom. It already had the browsers installed. What has changed here? So if we look, once we install Playwright, so let me see it from change directory. So you can see it got the latest version of Playwright, which is 1.62. It added a Playwright config spec here. And so it has all the standard stuff like the browsers and whatnot. It added an example spec if we want to see how Playwright looks. That's great. And if I wanted to just test, make sure that Playwright is working, I could say npx playwright test, and it should run that test spec. And it runs it on all three browsers. Boom, boom. Come on, WebKit. WebKit, why are you slow? Yeah, what a pain in the butt. Come on, man. Something tells me WebKit's going to fail. That's okay. We'll give it a moment to figure itself out. So if you go to the Playwright config spec, you can see here there's a projects entry, and this specifies all the different browsers that runs. Oh, sure enough, didn't like WebKit for some reason. That's not my problem. That's a Playwright problem. I don't know why I couldn't do that. Maybe there's something with the browser project, but that's okay. Here you can see the browsers that it's chosen. If you don't want to run certain browsers, what you can do is you can specify project on the command line and say something like Chromium. If I only want to run on Chromium, so 2 out of 2, bam. Another thing you could do is you could blank these out here. So that way they aren't going to be considered. So now if I just run npx playwright test, it will only run Chromium. Yeah. And if you didn't know how to do it, you could prompt the AI, hey, make sure this project runs Playwright tests only on Chromium. You could do a prompt like this. And in fact, I'll undo, boom. So now it's back to what it was. If we run this prompt, I'll check the Playwright config and configure so it only runs in Playwright on Chromium. And it'll probably do the same thing that I just did. So I'll drop this, bam. Ta-da, look at that, it's all gone. It did the thing. Okay, boom, great. And you can review, looks good, keep it, great, keep it. So it works. And now if I do it again, bam. Now you might be wondering, well, if I already knew how to make the change myself and I did it manually, why would I ask AI? If you know how to do it manually, just do it manually. Save yourself the token burn. But if you didn't know, because Playwright has like 100+ different settings, and I can't keep track of them all, sometimes it's easier to just describe it and ask it, hey, do this thing for me, right? It might sound stupid, but you know what? It's effective. It works. What is more costly? The little bit of token burn there, or the time it's taking you to go figure it out and fumble, right? What are you going to do? Go to Stack Overflow? Man, that was so like 10 years ago. Come on, man. Right? So use your best judgment. If you know how to do something, just do it. If you're not sure, it's okay to ask, right? Bam, right? I ask things all the time. Hey, can you make this button blue? Can you add 3 pixels of padding? Like, I don't want to go frick around with CSS. I mean, I remember in the past, like trying to make web pages picture perfect. The amount of time you twiddle CSS is such a waste, right? Now it's just like, just do it. Boom, it does it. It's wonderful. Powers of AI. Okay, so we have our project configured. What I want to do is, let's open up a new chat. So we talked earlier about the testing development workflow, right? Plan, generate, heal. In order to do that, not only do I need Playwright, but I need Playwright's AI tooling. Now with Playwright, I'm going to just lift over the doc page here for a moment. There are 2 ways in which you can use the Playwright tooling. You can use the MCP server, which is the older, more classic way, or you can use the CLI with skills. I think I mentioned this before, but I want to clarify now. MCP is far more token intensive than CLI, right? And so if you are trying to develop some agentic workflow that's distributed across multiple machines, like, hey, you want to have Playwright go scrape some things on a web page for other purposes, that's where MCP would really shine. If you're just doing test development like we're doing today, the CLI with skills is the better path. So I'm going to show how to use the CLI with skills. To install the CLI, it's best to do it globally, so everything on your machine can get it. I believe I already have it installed, but we'll just run it here again. So npm install -g for global Playwright CLI latest. Let that do its thing. Okay, so it had to update. Great. And so now what I can do is I can say, Playwright -CLI, and this Playwright CLI has all the commands. You can basically do everything you would in Playwright, like you would coding, from the CLI. And so because it's a CLI, now it can be provided as a tool locally to your AI agents. You just need some skills to guide the AI in how to use the tool that is the CLI. And it will use far fewer tokens than the MCP server. Humans aren't going to be using the Playwright CLI directly. It's more of like skills are going to use it. So, and as we said before, skills are markdown files that give very specific targeted tasks. So if we, again, pulling up that doc page I had earlier under Playwright CLI, there's a whole section on skills. And so if you want to install the skills, this is where you install the skills. Amazing, right? We love it. So I'm going to run that command. Bam. And so what you'll notice is that by default, it will install skills for Claude, but it adds the skills directory to your, what's it called? Your project here. And that's okay because skills are part of your project. Under here, you can see the markdown that explains the Playwright CLI skill, automated browser interactions. Amazing. It shows all these examples. And there's a whole references directory with all the different kinds of things it can do. And so baked into here, specifically under test generation, I believe. Yeah. Plan, generate, heal. Look at that. That workflow that we talked about, DFA, boom, documented as part of the skill. So I know I'm using cursor. Typically, you put cursor skills under cursor, but cursor does pick up Claude skills automatically. But I'm picky. Move the Claude skills under @Claude, oopsie, to the cursor skills. Right, it's the same dang markdown. Right, it'll do a little conversion here. I just like to be clean about it. But yeah, if you're working in a project that has Claude stuff and you're using cursor, cursor still sucks it in. I just want to be perfect, you know, because I'm like, that's what I care about. Okay, so give that a moment. It'll move it over. Bam, look at that. Freaking sweet. Boom. So there I have my rules for cursor. I have my skills for cursor. And it got rid of the Claude stuff. Yeah, bye-bye. Okay. So now we are set up like a champion. Okay, keep all these changes. That's good. Okay. So now that I have my skills, what I can do in the AI is I can do the / command and say Playwright CLI, and I can invoke that skill directly. You don't necessarily need to invoke skills directly. If you give it a prompt, the coding agent, as long as your instructions are good, will usually figure out to know what skills it needs to do. But if you're like, I want you to use this skill, invoke it directly. So that's what I'm going to do here. Now that we have this, what I want to do, I have my app running locally, right? So I want to start my plan, generate, heal cycle. So what I'm going to do is I'm going to show how I would prompt for this. So Playwright CLI. Generate test plans for the Buggy board web application. The specs for it are located under the @specs directory. So I'm saying, hey, I actually have all the behavior specified. You can use that for generating your test plans. You can also log into the app locally at the address using the user account credentials from users.json. What Playwright will do as well as part of exploration, it can log into your app and poke around. Why? Because it has the skills to be able to do that. And so you can use the specs, you can use the app exploration. And what I want to do is I want to say, put the test plans under a folder at specs/test plans. All right. Because I have all the context and because I have the application, this is all I need to do to give it the prompt. It has the skills, it has the context, and it should take only a few minutes to figure this out. So we're going to let that go. So it's saying, what's it doing? I'll follow the Playwright CLI skills on the Buggy board so we can generate test plans. Boom. So it's reading all those feature specs and setting up a seed. So if we look what's going to happen, the seed spec is something that it will need in order to know how to log into the application, right? And so anytime you do Playwright with AI, it's probably going to set up a seed spec. You can also manually set up your own seed spec. This is smart enough to know to do that on its own. And so it should pop out on the test directory pretty soon. Yep. So here, you see our seed spec. It's like, hey, go to this thing. It's probably also going to edit this to do login, but we'll see what it chooses. I could have been more explicit about that, right? If you don't like what it does, be more explicit. But yep, now it's going. It's got a .playwright CLI folder that's capturing a trace of everything it's doing. That you don't want to commit that to Git. It's just kind of like a local project thing. So we'll give it some time. I found that for this app, when I've done it before with the behaviors, it usually takes about like 5 minutes-ish to generate the test plans. I think behind the scenes, it is actually like it's doing this in headless mode, but it is actually opening up the page, logging in and poking around and finding out. It's doing it headless to make it go faster. If I wanted to make it do it faster, I could have just had it rip from the specs and it wouldn't be doing that. But I think it's kind of cool to just like show it's actually poking around. So while that goes, I'll pop over to Q&A and see if I can answer any of these real quick. Okay, so let's see here. First question, how can AI prioritize which Playwright test should run first based on recent code changes? What you can do is probably the best way to do this is like write a skill or a sub-agent or something where it can look at the Git log and see, hey, what's changed recently? Because Git is just a command line. It can go in there, it can see what changes, it can map that to like, oh, what commits affected what files. And then from there, it can say, you affected these files. Then that means I should run these kinds of tests that were supposed to cover those kinds of files. Now, it's not going to be perfect, but you can try to refine it down and get something like that. I know there are entire companies trying to solve that problem too. So, boom. What else do we have? Next question. How can we determine whether an AI-generated Playwright test is actually validating business behavior or simply validating that the UI works technically? That is an excellent question. So, that's what we call human. That's where we have human in the loop, right? As we see what this is doing here, as it's spinning, you can see that the AI is starting to generate test plans based on its recommendations, right? What I would be doing as a human is I would be coming in here and reviewing these test plans myself and making sure they're good. For example, this one, fave icon test plan. Buggy board brands the tab with a cartoon thing, serves us up. So it's having tests to see, hey, the fave icon should load. Okay, is that a test that we really want to automate? Maybe not, right? So I might remove this test plan, or I might tell AI, hey, this one isn't worth it, right? And so that's why we don't want to do one-shot things with this. We actually want it to have this kind of process, because every step in the process is the chance for human to enter the loop to inspect, right? These markdown plans here for the test plans, you can modify them yourself. Or you can have a conversation with the AI to say, hey, I don't think this is good. I think you should change this. You can challenge it and make it change, right? If you were to one-shot it, it would have done all this work, burned I don't know how many tokens, taken who knows how many hours, and just puked out a whole bunch of really bad test code. But because we have the process, we can insert ourselves, right? Also, specifically on like, how do we know it's doing actual business behavior rather than just UI clicking and tracing? That's where that context engineering came into place. That's where the spec-driven development came into place. Because if you're defining your specs are defining that business value and that desired behavior. And so if the AI generation with Playwright is accounting for that, then you can be more assured that it's actually testing meaningful things. Bam. Okay, so 2 questions answered. Very good questions. And we can see here now what the AI did, right? It added the test seed spec, explored all of the behaviors, and wrote a plan per feature plus a README. And so here you go. You've got all the different test plans. And I'm guessing it actually matched up to feature. Yep. So that's the reason it gave a favicon plan, is because there was a favicon spec for it. Boom, 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 boom. And so, yeah, like I said, we can review these test specs, right? If we wanted to, we could constrain how the plans are generated, what the formats of them are, all that good stuff. And so here for like login test scenarios, right? Login page should display the login page. Here are the steps it would take. Should redirect unauthenticated users to log in, right? Successful login. What I find is really interesting when it generates these test plans is, like, as humans, we kind of naturally think on the happy path, right? AI is really good about filling in all the extra stuff around that, negative cases, things we wouldn't have considered. And so I use this not as just like a blank take it by faith and go, but rather that I use this to learn and to think for myself. Sometimes what I found is that with this technique, AI suggests far more test cases than are probably worth automating. And so I use this to think like, hey, would this be worth it or not? Like we already mentioned for favicon, I'm not sure I'd want to automate that, right? But for these login things, these are actually pretty good catches that I may not have thought of initially or thought to put in my spec initially, right? Things like, trimming the white space, or, what the error messages are for security reasons, right? So all that to say, boom, we'll keep these. These look good. Whoa. So we've done the planning. Let's move on to generation. So again, I'll invoke my skill. Generate the Playwright tests for the test plan at. Now, I could have it generate all the tests for all these plans. There's 13 different plans. There's probably like order of magnitude 100 tests here. I could try to one-shot that. It would probably be okay, but take a little bit. Because we have limited time here in our workshop, I'm just going to pick one of the test plans and have it do that. Remember what I said about taking things step by step? That's what I'm going to do. So I'm going to pinpoint, at 03 login plan. And really, all I need to say is like generate it. Right? I could say make sure it works by running the test and heal any issues it may have, right? And so I'm going to make it loop on its own like that. So this moves forward into the generation piece, right? Now, as I said, make sure you review the test deeply. I did it very quickly here just because this is tutorial. If it were me in my day job, I would probably be spending several more minutes reading, thinking. I'd even be challenging the AI or making edits to this plan. But for the sake of our tutorial here, we'll just take it and go. So now this will take a few more minutes to run. And what we should have on the outcome is a new test under our test directory for the login tests. So we'll give that a moment to think. Usually the generation happens pretty quick if it's already got the test plan, because trying to go from like the human written spec to an actual Playwright test case, that's pretty straightforward for the AI. The forming the test plan takes a bit more time because it has to reason and think of like, what are the behaviors? What is actually possible? What is it doing? Right. Boom, boom, boom. So now it's editing Playwright config a little bit. That's fine. Let it do its thing. In the meantime, I will try to answer some more questions in the chat. So where does AI genuinely improve Playwright tests today beyond generating boilerplates? That is a great question. So what AI can do with Playwright, first of all, we've seen all the skills, right, that it adds. That adds the guidance of how you can do it. You can modify those skills. You can add more skills, right? You can add more context. Like I said before, I like to bake in page object model as part of my definitions. The other thing is the exploration piece, right? Like I said, Playwright is actually opening up my web app and poking through, right? That's really helpful because as it pokes through, it can actually capture real locators that will work, right? Now, given I have this Buggy Board app, the AI could have gone into the product code for the app and saw the DOM and the page structure and gotten the locators from there. But sometimes you don't have access to the project code. And so for Playwright to go into an application and actually like dance through the page, when it identifies the element it needs to click, it can capture that locator. And so it's going to be more correct. So it's not guessing and looping repeatedly. It knows for certain the first time. And so that's another way that Playwright can improve, or that AI can genuinely improve what Playwright can do today. Because rather than you looking at the page and trying to go into the source code and figure out what a locator should be, right? You can have that done for you with the AI tooling. So I found it to be an amazing boost. What we're going to see here is, these test plans. This probably would have taken me, several business days to be able to write out the test plans for these kinds of things. With the tests it's going to generate, right? It's probably going to generate about a half dozen tests at least, maybe more. When I was an SDET back in the day before AI, it would have been a good day if I could have finished automating 3 to 5 really good tests, right? Bulletproof, reliable, covering the actual behavior, right? Now it takes like 5 to 10 minutes to get even more tests. It's like, oh my gosh. So it's amazing speed up, right? Because I'm not spending my time worrying about the mechanics of what's the right locator here. I can move a whole lot faster, and that's a genuine boost. Okay. So next question here. How can we make AI-generated Playwright tests deterministic enough for enterprise CI/CD pipelines? Well, I think that answer comes down to the spec-driven development and the skills and the guidelines, right? If you try to one-shot things without any context, AI is going to go off the rails, as it always does. It's going to give you tests that are crap. But if you use these tools and these skills properly, and you have the appropriate context, and you have a process that you're following, then you're going to find that the Playwright tests are not, the generation of Playwright tests is not going to be completely deterministic, meaning you're never going to get the same exact code every single time. But what you will find is that you are going to get meaningful test cases that reliably work pretty much every time, with a little bit of human guidance in there. And I would posit this. You could have AI do all these things for you, and you might have concerns that AI is non-deterministic. Humans themselves are non-deterministic too. Let's say you have a team of testers trying to build out a Playwright project. They come in one day, do some tests. They come in the next day, do tests. Do you think that they would produce identical code day 1, day 2, day 3? No. So why are we so concerned about that for AI? What matters is that AI is doing the right things, not that AI is doing identical things. Same thing goes for humans. It's just with the test code with Playwright now, AI can generate it a whole lot faster than a group of humans can, right? So is that enterprise ready for CI/CD pipelines? I think so. 100%, absolutely. Okay. So, all right, we have some tests. Let's take a look here. So, where did it put them? All 13 login tests passed. So I have my tests. Whoa. Yeah. Bring that back up again. So I had my login test plan. Underneath my test directory, I have a new authenticated spec. That's the seed spec that actually does the authentication. Cool. And I have a folder called login. And under here, wow, I've got 13 different test specs. Out of the box, it's also using fixtures and page objects, which is pretty cool. Let's just look at one of these tests. So describe login page. Should display login page. It's got the login page fixture, which that's going to be using the login page objects. And so here's the page object with all the locators in it and all the different things to do about it. But we can see like, hey, what are the steps? Go to the app and then expect all these things to be true. Make sure login page is there, has this URL, this is visible, this is visible, this is visible, blah, 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 blah. Right. Cool. So it generated that test. Let's just pick another one here. Describe failed login. Okay. This test should throw an error for blank username password. So go to the login page, click the login button. We haven't put any username password in. What do we expect, right? It should have this alert. Please enter your username and password. Cool. Now, we might want to nuance exactly what these steps are and all that kind of stuff. Again, human in the loop, refine. Treat this as a starting point. But overall, straight out of the box, we have test coverage for this particular area of our app based on the specs, based on the app itself. And so far, the tests are working because it ran it and it worked. Great. So I know we are coming up on time. I see Harshit, you're back.
Yeah, we have about 4 minutes now. So far, such an engaging session. And it's great. You took a lot of questions while this was going on, so we have few questions to not worry about right now. But for the sake of time, let's quickly close this session because we have another one lined up right after this one.
Oh, okay, no problem.
Yeah.
So you said we have 4 minutes left. Okay, so I'm going to answer as many questions as I can in 4 minutes, and then we'll close up. So here we go. How can we determine whether AI-generated Playwright test is actually... Oh, wait, already did. Sorry. Next one that we haven't answered. What are the biggest challenges when using Playwright in a large production project? Biggest challenges when using Playwright? I mean, it's not so much about Playwright as it is about just like testing practice in general. If you are slinging AI slop in your tests, you're not using things like page objects and fixtures, you'll find that the code becomes more difficult to maintain as your project size grows. So making sure that you are not just using these tools like crazy, but following process, using established patterns, using the skills, right? Following the plan, generate, heal workflow, possibly even leveling up to spec-driven development. Those are all things that are going to help you, especially as your projects get bigger and go into production. Okay, so next question. Let's see here. How does Playwright's WebSocket-based driver avoid the race conditions seen in the old WebDriver models? So I will admit, I don't know all the inner workings of exactly how Playwright works. I do know that it uses debug protocols like the CDP for Chrome and stuff. Yeah, in terms of like the interactions and how they avoid the race condition of the waiting, like in Playwright, every single interaction has an actionability requirement. For example, like before you click it, it needs to be displayed and it needs to be enabled, right? If you go to the Playwright docs, there's a whole page about actionability. And so what Playwright does is it actively checks to make sure the thing is actionable before firing that interaction. So that would be how it handles it at the tool level. Inside the source code of Playwright, I don't know, but hopefully that can give some guidance. Let's see what else. Next question. I'm working with WebdriverIO. I would like to go to Playwright. Is it a good idea to migrate it with AI? Yes, absolutely. That's one of the stellar things that AI can do. You want to go from one tool to another, one framework to another, one language to another. AI can do it beautifully. Now, it might not be perfect, but it'll be a whole lot better than you doing it manually. I think, though, you might want to ask yourself, why do you want to convert your WebdriverIO test project to Playwright or whatever other framework? Typically, like that kind of thing, even with AI, is still a bit of work. And so is it that you are having problems in your current projects, right? And if so, what are those problems? Is it that the tests are bad themselves, or is it that there's a limitation in the tool or framework that you're using, right? If you're just porting bad tests from one tool to the other, you're still going to get bad results, right? So make sure you know why you're doing what you're doing and you're solving the right problems, right? Just moving to Playwright's not going to wave a magic wand and make it all better, though you might get some interesting efficiencies out of it. So just do things for the right reasons. Okay. All right, next question. If AI generates Playwright tests, how do we validate that the generated behaviors are actually testing the right business behavior rather than simply achieving code coverage? That's why you have to have human in the loop, right? You could even give extra context and guidance on those kinds of things, particular to your project. Like, hey, bro, don't check the fave icon, stuff like that, you know. But that's where the AI treat it like an ambitious intern that wants to impress you, right? Okay.
And that's gonna be it for now, because we have another session lined up. Thank you so much, Andrew, for that detailed walkthrough. We have so many questions still waiting to be answered. Don't worry, guys. We're gonna take all of them and answer all of them as we upload this to YouTube channel and also to our blog. So don't worry about it. We've got you covered. And hope on just tune on to the next sessions. This is just the start of the day 2 of TestMu Conf. Share your learnings over LinkedIn and X. Andrew, thank you so much once again for making time for this.
Thank you.
Lovely
And
having
thank
you
you.
always. Bye-bye, everyone.